Hi everyone, I'm Ben, and welcome to my presentation on how pressure-based insoles are transforming gait retraining for individuals recovering from a stroke. The objective of today is to explore how these innovative devices provide real-time feedback, helping patients regain their mobility and restore their confidence. First of all, wearable technologies can be integrated into clothes or worn as accessories on the body, and again provide real-time feedback to their users. Some examples include glasses, watches, headbands, and jewelry. Other examples include inertial measurement units, which are mostly attached to the sacrum and allow the quantification of acceleration and angular velocity, and are praised in health and rehabilitation biomechanics due to their low cost and transportability. Also, you have instrumented mouth guards. This was experimented by Waldron et al. 2021, who incorporated an accelerometer into the mouth guards to quantify head impact thresholds to assess collisions that may cause a concussion. Also, you have pressure insoles, which allow the user to quantify improvements in their gait. They offer a valuable way to monitor walking function during stroke recovery, providing feedback for both patients and clinicians in order to help guide treatment plans, track their progress, and prompt adjustments to care if a decrease in physical activity is detected. We will delve further into this as we progress through the presentation. Now, what are pressure-based insoles? They are essentially integrated into shoes, which allows them to be compact and portable, as was seen by Nam et al. 2024, who found insole pressure sensors to be non-obtrusive to gait, indicated by a strong correlation and high agreement between gait speeds with and without insole. They also allow the accurate detection of gait events, such as foot striking foot off. In addition, they have been developed over the past decade to be wireless, which may enable the assessment of ground reaction forces and center of pressure trajectories during functional activities in a real-world setting and offer higher efficiency, flexibility, and mobility than traditional laboratory-based force and pressure plates. There are different types as well. For example, you've got capacitive sensors which detect force by measuring distance changes between electrodes. You've also got piezoresistive sensors which change resistance with mechanical stress, and you've got piezoelectric. And all of these combined essentially measure plantar force. Piezoresistive sensors are cost-effective with a broad measurement range, but have low repeatability and are affected by temperature and humidity. Capacitive and piezoelectric sensors provide high sensitivity to force, but are vulnerable to temperature changes and electromagnetic interference. Piezoresistive insoles have been validated by Smith et al. 2002, where they accurately identified 94.5% of steps with high recall and precision. However, this was done in neurological disorders except stroke. However, it could be assumed that they would find similar results in a stroke population. And finally, it's important to be able to quantify force generated at certain regions, as acknowledged by Chen et al. 2022, where they essentially mentioned how the layout of pressure sensors should match the features of their disease of interest. For example, on the right here, you can see a diagram by Wang et al. 2019, who set 10 sensors at the first and third metatarsophalangeal joints, metatarsal bones, and the heel to quantify plantar pressure to determine walk-in speed and gait asymmetries. And now, it must be noted that strokes are a significant global health concern, where they've led to 12.2 million cases worldwide, according to Rajsik et al. 2018. Also, more than 80% of stroke survivors will experience gait impairment. And there are essentially two types of stroke. You've got hemiparesis, which is a weakness on one side of the body, and patients who experience gait impairments should expect to experience a decreased cadence, prolonged sprint duration on the paretic side, and prolonged stance duration on the non-paretic side, along with varied step length and asymmetry comparatively to healthy patients, essentially. You also have hemiplegia, which is total paralysis of one side of the body, and their gait patterns are essentially associated with a reduced gait speed, cadence, stride length, and a increased left to right asymmetry during walking. And also, the goals of rehabilitation is to restore mobility and increase participation in normal activities, as this would help increase the confidence of the patient and also help to achieve their each patient's potential for recovery, including patient-tailored counselling to maintain and increase physical activity and to promote self-training outside of the therapeutic setting. Now, it's also important to accurately detect gait events. However, it must be noted that it is challenging, especially in neurologically diverse populations, such as stroke patients, as they have variable gait patterns and speeds. So, Farid et al. 2020 essentially validated the FeetMe monitor system, and they found essentially it exhibited a intra-class correlation coefficient of 0.77 and a test-retest reliability of 0.9. In addition, Lefebvre et al. 2019 demonstrated their pressure insoles, which show good to excellent ICCs in gait cycle time, cadence, stride length, and stride velocity in patients who don't exhibit severe dragging of the paretic foot. To expand, Renner, Williams, and Queen 2019 observed excellent between-day reliability for both running and walking using low soles. However, these results were from recreationally active individuals and not stroke patients, and it must be noted that stroke patients also exhibit inter-individual gait asymmetries. Therefore, it's important to test this population. However, Newman et al. 2024 did demonstrate the accuracy of identifying gait events in stroke patients, as across all of the 3,820 gait events, the insole pressure system identified 90.86% of all these gait events. Now I'm going to compare a plantar platform system and the in-shoe systems. So first of all, the plantar platform offers a high resolution and also a stable data collection, but is restricted by short length, depending on the lab. April et al. 2018 acknowledged that the platform's limited length in indoor labs requires precise foot targeting, which can potentially disrupt normal gait and stepping comfort, which can exacerbate these gait pathologies. In comparison, the in-shoe system is flexible and portable with no foot placement restrictions, which means it can essentially adapt to different heel types and shoes, but has reduced sensor sensitivity as the plantar system has its sensors parallel, so more sensitivity to the plantar force. However, the sensor space is restricted to the size of the insole, and which can also lead to the buildup of heat, which can disrupt the functional ability of the sensors to detect plantar pressure. Now, to conclude, developing wearable technologies is a very positive thing because it means they offer new innovative solutions for monitoring health and rehabilitation, not just in stroke patients, but in other neurological pathologies as well, for example, Parkinson's or diabetes. Also, strokes are a serious health concern, which does lead to gait impairments, so the pressure insole systems are highly needed in order to reduce these and to correct the gait as well. There's also good accuracy, as we have covered numerous studies which have validated different pressure insoles to show how accurate they are. And finally, the Finally, developing new pressure-based insoles is crucial because they offer real-time objective feedback on foot pressure, distribution and gait patterns, which is essential for effective rehabilitation of stroke patients. And for individuals recovering from a stroke, these insoles help identify and correct asymmetries to improve balance and reduce fall risk. They also empower therapists to tailor interventions more precisely and track progress over time, ultimately enhancing recovery outcomes and promoting greater independence for patients. Thank you very much for listening and have a nice day.